This video is a summary of the work that you did with optimizing area and perimeter. So we'll start with maximizing the area. So if we want to make a rectangle that has the biggest possible area given a certain perimeter, hopefully you remember that what you had to do here was to make a square. So if you want it as big as possible, make it a square. Just a reminder, a square is a rectangle. It is a special kind of rectangle where all of the side lengths are the same. But if we want to make the biggest possible area, we take the perimeter and divide it by 4 to make a square. And that's what the next point here, bullet says. It says divide the perimeter by 4 to get the length of the square. Let's work through an example so you can see what that looks like. So here the question asks, find the dimension of the largest rectangle that could be made with 100 meters of fencing. Because it's asking us for the largest rectangle, that's an indication that we're trying to create the maximum area. So when we say the largest rectangle, the one that has the largest area. We know already that if it's going to be the largest area, it needs to be a square. And if it's going to be a square, we have 100 meters of fencing. Remember, the perimeter is the distance all around the outside. So this distance all around here, when we add them all up, should give us 100 meters of fencing. We have 100 meters of fence. We want it on 4 equal sides. So we take that 100 and divide it by 4, and we get 25. That means we want to create a rectangle that's a square. We'll just draw another picture of it down here. That is 25 here and 25 here. You can check to make sure the area still, the perimeter is the length around the outside. So 25 plus 25 is 50, plus 25 plus 25 is another 50, so that gives us 100 in total. So we still have 100 meters of fencing, and this gives us the largest possible area. So the length of this rectangle is equal to 25. The width is also equal to 25. And then the area, if we were asked to calculate the area, the largest possible area, remember for a rectangle is length times width, which is going to be 25 times 25, which works out to 625 units squared. In this case it was meters, so it'll be meters squared. So that's how we can make the largest possible area. Let's flip things around a little bit and say that we're given a certain area. How do we, minimize, not the area, but how do we minimize the perimeter? So I'm just going to change this up here because we want to minimize the perimeter. So in order to minimize the perimeter, we do a similar sort of thing. We make a rectangle. Oh, sorry, another typo here. If we want to make a perimeter, minimize the perimeter with a certain area, again, we still make it a square, but now we have to actually take the square root. So I want to show you why that is, and we'll just kind of talk through this. So find the dimensions of the rectangle with the smallest perimeter that covers an area of 100 meters squared. So remember the area, I'm going to just draw a rectangle. Oh, sorry, hang on, I hit a wrong button. I'm going to draw a rectangle that has an area of 100 meters squared. I'm not going to draw the one with the smallest perimeter, but I'm going to pick one. Remember the way we find the area of a rectangle is length times width. So I'm going to pick an easy one here. 1 times 100. This would have an area of 100 meters squared. And we can find the perimeter of this rectangle just by adding up all the side lengths. 1 plus 100 plus another 1 plus 100 would give us 102. We want to find the smallest perimeter we can to enclose 100 meters squared. So this might be the case if you wanted to make a pen for your dog. You wanted to have a certain area and you wanted to minimize the cost and have the least amount of cost for fencing. You would want the smallest perimeter. So let's work through this example. So we know for sure we want 100 square meters and we want the smallest perimeter. I can tell you that this isn't the smallest perimeter because we haven't done this part. In order to find the smallest possible area, we take the square root of the perimeter, and that's going to give us our side lengths. We're still going to create a square. Whenever we optimize, we generally want a square, not always, but often. And our length and our width is going to equal the square root of 100. Well, the square root of 100 is just 10. So the side length here will be 10, the side length here will be 10. And again, just double check to make sure that you have these numbers right. So the area here would equal the length times the width, which is 10 times 10. 10 times 10 gives us 100, and again, we can find the perimeter here. The perimeter here would equal, and again, we weren't asked for this, but let's calculate it anyway. The perimeter would just be 4 times 10, or 10 plus 10 plus 10 plus 10, which is equal to 40 meters in this case, which is quite a bit smaller than this 102 meters that we had over here. So that's how we can create a rectangle with a certain area that has the smallest possible perimeter. I want to look at one other case here that's kind of important. So let's say instead of making a rectangular pen, you decided to fence off 3 sides of a pen. So let's say you're putting this pen up against a barn or a house or something. So here's a barn or a house, and you want to make a pen right here that encloses, you know, for your dog or for a, I don't know, chicken or whatever. And if this is the case, what we do is we still make a square. So we say, well, let's make the square. Let's take the square, and I'll put some numbers on this in a second. But let's take the square, and instead of putting this piece right here, because we don't need it, it's up against the wall, instead of using that piece, we're going to take that piece and we stick it on the opposite side. That will give us the largest possible area, or the smallest possible perimeter. So let's have a quick peek at an example here. So let's say we had 40 meters of fencing that we wanted to use in total, but we only wanted our pen to go on 3 sides. So this is the difference here between the examples that we did before and the example now. So we want this scenario here. So we still make a square, like this one right here. If it's a square, all sides are going to have the same length. So the length of the square is going to equal 40 divided by 4, because there are 4 sides, which would be 10 meters. So for the square, each side length would be 10 meters. 10 meters here, 10 meters here, 10 over here, and 10 over here. Except we already know that we don't need this side here in red. We take it to the opposite side and use it there instead. So what ends up happening is we end up with one side that's 10 meters and the other side that's twice as long. So this is the example that I meant earlier when I said that we move on to something that's not a square. So this now ends up twice as long because we've taken the side length from over here and put it over here. So in this case, the dimensions of the rectangle would be 10 by 20. The length and the width would be half or double each other because we didn't need that extra side. So I just wanted to show you that as an example. So that was a video on how to optimize area and perimeter, create the largest possible area with the smallest perimeter, or the smallest perimeter with a certain area.